Okay, thank you so much. I'm here to present a new initiative that came up on the East Coast, and it's shame advertising. So because I want you to participate in it. And I'm by no means the only one involved in it. Thank goodness there are a bunch of. This is the extra 30 seconds. By no means I'm the only one here involved in it. Thank goodness there are a bunch of other co-spirators. The main person responsible for this is with me. It's Harm van Avendonk at UTIG in Austin. And some of these people are here. So if you have any questions, just talk to me or grab Maggie Benoit or Maureen Long. But there are other people, Lamont, like Donna Shillington, Jim Garty, and Ann Basile, and then another person at SMU, Brandon, Matt Ornbach, Brandon Dagan at Rice, and Dan Lizaraldi at Woods Hole. And then Steve Harder is also here, so you can go talk to him about it. And then Gil Christensen at UT Austin. And we expect to involve way more scientists as the initiative goes to the field. OK, so we've been talking a lot about community experiments. And so I thought I would put up an explanation of what do we mean by community experiments. It's a rather new concept, at least for the GeoPrism group. And so by looking at the GeoPrism implementation plan, what makes a community experiment is an experiment that is planned and executed by the community, unlike any other experiment that is instead is PI-driven. And the purpose of it is to acquire a large data set. It could be a geophysical. In this case, it's a seismological data set that might be beyond the capabilities of a single PI or a group of PI. The main difference is what Ken was actually mentioning is this open data access. So there is no embargo. The data becomes available immediately upon acquisition and maybe a little bit of a QC of the data. And there is an involvement of training of junior scientists and students that is a little bit more involved than just the normal bringing your graduate students to the field. And because of this reason, we actually did not put any funding for analysis of the data in the proposal beyond the reduction of the data. And this approach enables a much larger group of people to benefit quickly from the data and the broader community to make a larger impact. So why did we want to do an experiment in the east margin of North America? Well, there was a synergy that came into being almost at the same time. And the main driver was the fact that GeoPrism selected the ENAM site as the focus site for the rift initiation and evolution. So we felt the need to acquire and gather active source data and broadband seismic data in the same portion of the margin. And then, of course, there was EarthScope. EarthScope is arriving on the East Coast in 2013 and 2014. So we saw the synergy with that opportunity. And then there is the USGS plan to acquire data beyond the 200 nautical miles to fulfill the requirement for the United Nations Convention of Law of the Sea, which is to find the extended continental shelf. And a renewed interest for energy companies that want to look at the margin from the asthenosphere all the way up to the sedimentary basins. And of course, then there is also, like Ken was mentioning, the need to grow and strengthen the field-oriented seismological community, which is somehow shrinking rapidly, at least in the active source community. So our main science goals and objectives were to understand the roles of inheritance and magmatism on rifting and rupture, mainly to understand what controls the architecture of the rifted continental margins during and after breakup. And then once you build these rifted margins, how this product of rifting have an impact on the evolution and how this impact is expressed on surface processes and active tectonics today. And we realized immediately that to address these questions, We needed to have observation that were spanning from the Appalachians all the way through the transitional crust and lithosphere into the ancient ocean, and across this expanse from the shallow structure into the crust and then into the lithosphere, and maybe across this on multi-scale observation from the high resolution all the way down to the broadband. And so just a few words on the segmentation and the inheritance problem. This is just a slide that shows the segmentation as observed, the Bill Thomas slide. Everybody's probably familiar with it. The segmentation along strike of the margin. And then I put there two profiles as of acquired offshore, the last and the edge profile, that show how different the margin is to the north and to the south of that transform that Bill Thomas suggests is present there. And you see that the two margins are completely different, although the shape of the transition is different. And that transition actually corresponds to an onshore strong transition in the structure of the Appalachian origin, the transition between the northern and the southern Appalachian, and corresponds offshore to a difference in the elastic thickness of the lithosphere, which reflects a juxtaposition of strong and weak blocks, which suggests segmentation offshore, which plays a role in the way the margin has been controlled maybe by the structure of the Appalachian, and is still playing a control, for example, in the amount of sediments that are sedimented there. You see that to the north, you have 15 kilometers of sediments, and to the south, you have only 8. And as you build this architecture of the margin, then this is a slide. This shows the coast from Cape Hatteras to the south here. Can you see the mouse here? And all the way out to New England. You see, this is the margin is prone to geohazard, in this case, slope stability. And the slope stability is instability, rather, is triggered by different factors. For example, earthquakes, or depositional processes, or hydrate dissociation. And these triggers are different depending on where you are along the coast and along the margin. For example, earthquakes are more predominant to the north, where the margin is responding to glacial unloading. And that transition happens roughly at Cape Hatteras. To the north, the trigger is mostly earthquakes. To the south is mostly dominated by depositional processes and hydrated dissociation. So how did a little bit of history on how we came to do a community experiment in East North American margin. The first idea of a community experiment came to a workshop sponsored by GeoPrism and EarthScope at Lehigh University. There, scientists at that workshop realized there was a sizable opportunity to acquire data at different scales, from the mantle to the surface processes, for example. And also they saw that there was an unprecedented opportunity to take advantage of the connection between EarthScope and GeoPrism and the USGS extended continental shelf. And there was an opportunity to capitalize on those efforts as much as possible. And then so Harm and I got a phone call from Julie Morgan. I don't know if Julie's here still. She was here yesterday. And she said, "Do you want to be the hero for this community experiment?" And I'll say, well, it sounded more like martyrs to me. So she said, okay, you need to find other volunteers that will help you. And so together, Harm and I put together a mini workshop at AGU in December 2011. And that was the first time that we put down real plans for discussing possible scenarios where and what we were going to do for a community experiment. And then, so these martyrs or volunteers or heroes, what you want to call them, came together, and we gathered community input by email, having a GeoPrism website where people could come and say, we would like to do this or that here or there along the margin, and mainly based on the corridors that were selected at the GeoPrism Lehigh workshop. And in May 2012, we had a straw poll to select the target areas for where we were going to do the the experiment. And then in July, finally, July 2012, we submitted the proposal, and we received notification of funding last month. So we're going to go in the field 2014, and this is the reason why I'm here in front of you. And there's going to be an acquisition of active source seismic data, which is going to be released in 2014. And the broadband seismic data is going to be released in 2015. And so we had 3 corridors. This is just the results of the straw poll. We had the Philadelphia, the Richmond, and the Charleston corridor. And the Charleston and the Richmond corridor are the one that received most of the votes. Actually, they tied. So because we had a need to understand the 3D complexity, that need argued against a split in data acquisition between the Richmond and the Charleston corridor. That was a very difficult decision to make, and we actually decided to choose Cape Hatteras as a compromise between the Richmond and the Charleston corridor. This is also a place where the Blue Ridge and the terrains are coming close to the coast. It is also the place where there's a major lithospheric boundary between the Brunswick magnetic anomaly and the East Coast magnetic anomaly, right here. See, this area is where the Brunswick magnetic anomaly comes into contact with the East Coast magnetic anomaly, where the Carolina Trough meets the Baltimore Canyon Trough. Here there are also the Kane fracture zone and the northern fracture zone are coming close to shore. There's a narrow shelf, which it's a very shallow water is not a good environment for OBSs, for broadband OBSs like we saw yesterday. And also this is the area that marks the transition between the character of the landslide to the north and to the south. So we selected this Cape Hatteras as one of our target area. This is also the area where many research teams can be addressed, like the amalgamation of terrains, the extension and magmatism along the North American Rift system, the formation of the earliest oceanic crust, the post-rift margin tectonics, and all that. So a large community experiment offered the possibility of addressing the complexity of this margin through a dense 2D and some 3D constraints. So we submitted a proposal, and this is the original layout that we submitted. And I'm going to spend some time explaining you this. This is an onshore-offshore, passive and active source acquisition. What you see here, you see onshore and offshore refraction profiles. We have 2 deep lines and 3 strike profiles. With on land, we're going to deploy RT-125, the Texans, and along each profile. And we're going to put an array of RT-130s in 3 components that are going to record the entire experiments. We're going to have 7 land shots. And then the original plan, and then there are going to be OBSs, short-term OBSs offshore, and that are going to record the air guns of the Lancet. And then there is a footprint of broadband stations that is going to replicate, extend the TA on the ocean floor. And there are 2 footprints. One is the wider one that you see there, and there is a tighter array here that targets the East Coast magnetic anomaly as it comes into contact with the Brunswick magnetic anomaly. And then there is an additional set of multi-channel reflection data that addresses the high-resolution problems like the Cape Fear landslide, the Cape Lookout landslide, and other surface processes up here. So this is what we proposed, and NSF came back to us and asked us to cut 20% standard. So this is actually what is going to happen. And as you see, it is similar. We think we can still address many of the science questions, although there is some, there has been some necessary cut in the geometry of acquisition. And I really hope that this community can make up for that and maybe suggest some additional piggyback acquisitions to make up for what we lost. So what we lost is a strike profile on land. And that was supposed to address the continuity of the fracture zone as it comes into land. And so that would be a nice target for this community. We removed a substantial amount of multi-channel acquisition offshore, but we maintained the footprint of the broadband, although instead of having 60 broadband instruments, we're going to have 30 broadband OBSs in an area array that is pretty much the same area. OK, how is this going to happen? We're going to have one leg of 33 days on the Lancet for marine seismic reflection shooting. We're going to have 2 days on the NOR for the broadband OBS deployment and recovery. We're going to have one leg on the Endeavor for the short period OBSs. And then we're going to have 39 days on land, onshore, offshore recovery, recording and exploration seismology, sorry. So this is where I really want you to, especially if you're a student or a postdoc or an early science, or if you don't know how to do this and you want to learn, these are the people you want to keep in mind. This is who is leading each effort. Harm and Brandon are in charge of the OBSs. Donna, Matt, and Anne are in charge of the offshore multi-channel recording. I'm in charge with Dan of the sea land recording of the RT-130s and RT-125s. Steve and I are in charge of the explosion seismology. And Jim and Maggie and Maureen are in charge of the broadband OBSs. So if you want to participate in any of this field campaign, please come and talk to us. And we'll be happy to bring you on board, bring you to the field, and make you work. So we want to get people to the field by application. We're going to send out an invitation by application. We want to involve young scientists and students. And all the travel costs are in the budget. So it's at no cost to you or your students. So these are what is available. We need a lot of people, as you can tell. So, come to the field with us. What do we expect to get? Mainly integrated images of sediments, of crust, and mantle seismic structures. So this is an example of the edge line that I showed you before. So we know that syndrift magmatism has a dramatic expression in the crust. And we expect that, so you see there are the seaward dipping reflection. Those are, they're supposed to represent the transitional crust and an expression of the magmatism and an expression of this rift-to-drift process. We expect to see a complementary expression of that magmatism into the mantle and in the mantle lithosphere so that we could compare the continental structure to the west and the oceanic structure to the east, and then see the difference and see the character of this anomaly of depletion in the mantle fabric. And then we expect also to see difference. We can acquire, the Lancet has this capability of acquiring high-resolution images by towing the streamer at different depths and sampling, different sampling rates. So this is a slide that shows the same streamer just towed in the same area, just towed at different depths and at different sampling rates, so that we could actually see structures within the sedimentary deposit, for example, so that we can understand, by looking at higher resolution, we could look at the structures within this sedimentary deposit, and then looking at the larger scale, we might address what controls those cyclic deposit, for example, and the recurrence interval of those shallow events. Following the acquisition, we plan to have 2 training workshops, one for the multi-channel reflection data. 1 week is led by me and Donna and Anne, and it's going to be at Lamont. And the final product of that is going to be the migrated sections that are going to go and be released to the community. And then there's going to be a wide-angle data analysis workshop 1 week in UT Austin, led by Harm and Gail Christensen. And again, this will be, the final product will be tomographic images based on first arrival phases. So, and all this data will be archived and released to the public after the workshops. Again, data will be archived at IRIS DMC and another marine seismic data center, probably Lamont and UTIG. And just as a bonus, added bonus, we, Harmony and a few other PIs submitted another proposal. This is not funded, but it's an add-on to this, the proposal I just mentioned. This is, we called it the ENAM 2. It's proposed for funding to industry, and the plan is to extend the acquisition. It's an onshore, offshore, broadband, and multi-channel to the south, to the Blake Plateau. And it's going to be, if funded, is going to take place in April 2014. It's going to be offshore Charleston, and it's going to be offshore, onshore OBSs and RT-130s, and multi-channel data. And I'm going to leave the conclusion here. Gary Pavlis doesn't believe in reading them, so I'm not going to read them. And that's it. Thank you.